test we shall use. For the comparison test, just like the name suggests, we're going to be comparing two different things, two different series actually. We're going to start with our regular A sub n series, but we're going to compare that to another series, call it B sub n, and we'll see how we might want those comparison series to work. And the deal is, the B sub n's typically we want it to be an easier, nicer series, okay? Because there are some things that we can make note of. All right, here is the actual statement of the comparison test. If, well, suppose, say it this way, write it as my paper. Suppose A sub n, series, B sub n, are series with positive terms. So there is a stipulation here, again, positive terms. Are series with positive terms. The first part of the comparison test says this: if the series B sub n converges and the A sub n terms are all less than or equal to B sub n terms. All right, now this kind of gets back to the integral test thing that we were talking about. We've got B sub n convergent. The A sub n terms are all less than B sub n terms. So what can we say about A sub n? It's going to have to converge too, because the A sub n's are smaller than the B sub n's. So the A sub n series must converge too. Okay, well, guess what part 2 does? Kind of goes the other way. If the series B sub n diverges and the A sub n's are greater than or equal to the B sub n's, then the series B sub n, A sub n diverges. Okay? All right. So there's really, in each part of the comparison test, there's two things. You've got your B sub n is convergent, and then you also have the A sub n's are less than the B sub n's in part 1. In part 2, you've got the B sub n diverges, but you also have the A sub n's greater than the B sub n's. Now, what if it so happens B sub n diverges and A sub n is less than B sub n? What happens to the comparison test? It's a no-go, okay? If the B sub n diverges and A sub n's are less than B sub n, the comparison test tells you nothing, because it just tells you the B sub n diverges and the A sub n's are less than the B sub n's. Well, B sub n diverging means the limit goes to infinity, basically, right? Well, what's less than infinity? There's lots of things less than infinity. 1's less than infinity. 2's less than infinity. With me? So it has to be, these things, each one has to have both things. B sub n converges, A sub n less. B sub n diverges, A sub n bigger than B sub n. Okay? All right. So let's use this on a couple of series. How about we do this one? Series 5 over 3n squared plus 2. Okay, we're going to use the comparison test. All right, so this is our A sub n. Usually, for the B sub n, if we're going to use a comparison test, the B sub n we're going to use the ratio of the leading terms. So in this case, 5 over 3n squared. That's going to be our comparison series. Okay, you with me? Just the ratio of the leading terms. That makes it, well, that makes it a nicer series, doesn't it? Because what do you know about b sub n here? Well, it's 5/3. Let me write it this way. 5/3, we can pull that out. 1 over n squared. Now what do you know about that series? Just what we talked about. That's a p series. That's a p series. P is 2. Convergent, yes. I got myself a convergent p series right there. Okay, so for the comparison test, that's not the series I was wanting to know about though, but it gives me a comparison. Okay, and so if the comparison test is going to work, I'm going to have to then compare my a sub n compared to b sub n, and for this to work, since I've got convergent b sub n, won't it have to be this? Is that true? Are my a sub n's less than my b sub n's? That's what I need to consider. All right, well, the a sub n's, 5 over 3n squared plus 2. Compare that to 5 over 3n squared. Is it less? Because if it's not less, we're in trouble. Or the comparison test will do us no good. If it's greater. Well, let's think about this. This right here, it's pretty complicated, I guess, but think about it. Comparison to this, from this compared to that. This one has a bigger denominator, doesn't it? Because I'm adding 2 to whatever denominator this is, right? So I have 5 with a bigger denominator compared to that thing with a denominator. Won't this be a smaller number? Yes, true. 5 over 3n squared plus 2 is less than or equal to, matter of fact, I could say just less than, 5 over 3n squared, isn't it? Because it has a bigger denominator. In each case. Now, what if that had happened to have been 3n squared minus 2? Well, it would have a smaller denominator, and so this term would be bigger than that term, wouldn't it? With a bigger denominator, 5 divided by something smaller denominator would be bigger than what you got over here. So if that was minus 2, that would make a big, big difference. Okay? But since it's plus 2, we've got a bigger denominator, so this would be a smaller number than you got over here. We're good. We're all good because this is less, this is convergent, so your series is 5 over 3n squared plus 2 is convergent by the comparison test. And I would, since we're getting so many tests here, that's why I'm each time writing why I'm saying this is convergent. This one's convergent because of the comparison test. I've got show all this. Okay? How about another one? If you're okay with that. Is this okay? Series 1 over 3 to the n plus 4. Use a comparison test on that. All right, so my comparison here, that's a sub n. What's b sub n going to be? Probably would go with 1 over 3 to the n. What do you know about that series? Well, that's also known as, wouldn't it, 1/3 to the n, which is geometric. R is 1/3. or you know about geometric R equals 1/3 series. It's convergent also. Okay? So for the comparison test to work, then we need, is it true A sub n is less than B sub n? Well, that would say 1 over 3 to the n plus 4. Compare that to 1 over just 3 to the n. Is that less? Greater? It's less, isn't it? Why is it less? Same reason it was less a while ago, right? This is adding 4 to the denominator over here, so we've got a bigger denominator over here. 1 divided by a bigger denominator is going to be smaller, isn't it? So the denominator is bigger, therefore this term would be smaller. So this is another convergent series. By comparison test. Okay? Get the idea? All right. See how I do on this one. Four over 2n minus 3. Well, we compare that to what? My B sub n series would be 4 over 2n, leading parts, which is 2 over n. What do you know about that series? A couple ways you could look at that series. Number one series is, it's P series. P is 1, or call it a harmonic series. Yeah. Usually if it's a harmonic series, they say it's a harmonic series. So that's divergent. Well, for the comparison test to work, then we need greater than, right? A sub n greater than B sub n. Is that true? Well, A sub n, 4 over 2 to the 2n minus 3, 4 over 2 to the n. What do you got? This has a smaller denominator, so this would be bigger than that, which is what we need. Check. Check. Comparison series diverges. The terms of the original series are greater than the series of the B sub n's terms. That series diverges.